Are you constantly asking yourself if there's a better, lighter, cheaper solution to a design challenge than what you have come up with? Are you struggling to reduce the weight of your design while meeting the design constraints? Or do you find yourself battling thermal, vibration, or shock loads to your design that you should really be testing for? If you have considered SolidWorks Premium, you're already half your way there. SolidWorks Premium allows you to perform linear static analysis, where you can apply dead loads on a design to determine the failure points based on stresses and deflections. But wait, did you know that you can get the whole gamut of linear failure analysis and actually automate the process of design shape optimization if you combine your SolidWorks investment with Simulation Professional? Here are the top 3 reasons why you should really be looking at Simulation Professional. Reason 1. Automated design optimization. In this model, we performed a stress analysis using SolidWorks Premium. SolidWorks Premium tells us how safe the design is based on the applied load. You can see here that the original design is 3 times as safe, too safe for its application. The goal is to make the product lighter while keeping its safety factor above 2. Let's look at the dimensions that can change. In this case, it's the outer diameter, wall thickness, and the center distance with defined ranges. What combination of these 3 dimensions is the final solution? Well, let's ask Simulation Professional for the answer. Notice that in a few easy steps, we can define the variables and the constraints to be met. Our goal is to make this product as light as possible. Let's allow optimization to take over and determine the optimal combination of these dimensions that will give us the lightest product that meets our design constraints. The solution to this problem shows that with these dimensions, we achieved a 25% weight reduction while meeting our safety factor requirements. This automated process is easy to use and highly efficient and should be a part of every engineer's arsenal. Reason 2. Fatigue failure estimation. Let's take a look on how it's possible to determine the longevity of a design using Simulation Professional. Using SolidWorks Premium, it's already been determined that the safety factor of this design is almost 2. This passes the design goal. However, will it last its intended life of 500,000 cycles? In Simulation Professional, we can create a plot that shows the areas that are prone to fatigue-based failure over infinite cycles. This model exhibits areas that should be of concern. Let's move to a more detailed study that allows us to input the number of cycles of loading and the behavior of the material under cyclic loads. Running the analysis allows the software to calculate the cumulative damage after repeated loading. Notice that we're able to subsequently look at the damage in the model after 500,000 cycles. The lone area that fails is this web here. Everywhere else, the model has only reached about 50% of its life. Another way to examine these results is to look at the life plot. This plot tells us that the top of the web will only last 372,000 cycles before cracks begin to appear. The fact that we're inside SolidWorks allows us to quickly make a design modification, such as adding a fillet to remove the sharp corner. This allows the stresses to be spread out and hence increases the life of the product. Testing this subsequently in our 2 studies confirms that our design will address the lifespan of the product. Fatigue failure estimation is an important asset to every engineer who builds products that see repeated loading. Reason 3. Analysis of multiple failure modes such as thermal and vibration testing. Thermal management is an important design criterion when working with bodies generating heat. The chip shown here is generating 5 watts of heat power that is being conducted into the casing and the connector pins. A quick thermal analysis can be done where the heat source and the rate of convection are defined to account for the net heat transfer. Conduction, convection, and radiation can be studied simultaneously to determine the thermal signature of the heat source. The result plot shows us the temperature in the different zones on this model. We can also extract the resultant heat flux, which shows the direction of heat flow through the components. Transient analyses and thermal stress multiphysics are added perks at the Simulation Professional level. Let's move on into a vibration example. Take a look at this lawnmower muffler guard designed to be mounted at 2 different locations. A typical lawnmower operates at about 3000 RPM or approximately 50 Hz. When we run a vibration study on this model, it becomes apparent that at least 2 natural frequencies of this design lie in the vicinity of 50 Hz. This is not good for the design, since such resonant frequencies will induce higher stresses and deflections and contribute to noise and early failure. A quick animation of these two modes shows us the direction that needs to be constrained. Let's add an additional mounting location and quickly confirm our design decision. A subsequent rerun of the vibration study shows that the fundamental natural frequency is 96 Hz. This is far away from the operating frequency and is a much quieter, safer, and stronger design than the initial concept. These are just a few of the many benefits that Simulation Professional offers. It also comes with more failure mode analyses such as buckling, drop testing, and pressure vessel analysis, as well as additional features such as 2D simplification, trend tracking, FEA translators, and so on. To learn how you can make this a part of your everyday design process, please talk to your account manager at 3D Vision Technologies.